Okay, so compound interest. All right, look at an example here. So comparing simple and compound interest first. Okay, so a bond is a type of investment that you buy with cash and for which you receive interest either as the bond matures or when it matures. Okay, so as the bond matures, that means over time, or you have to wait till the very end and then the insurance is applied. Okay, a conventional bond generates an interest payment, sometimes called a coupon payment, on a regular basis, typically twice a year. Okay, so that means they calculate the interest on the amount of cash that you gave, okay, twice a year. Okay, the interest payments end when the bond matures, and the amount you paid upfront is then returned to you. Okay. A zero coupon bond, on the other hand, requires you to invest less money up front and pays you its maturity value, which includes all accumulated interest when the bond matures. Over the life of the bond, the interest that is earned each period itself earns interest until the bond matures. Okay? So the difference here, basic difference, is the type of interest earned. A conventional bond pays simple interest, whereas a zero coupon bond pays compound interest, which is interest that then earns interest. Okay? So let's take a look here at an example. So for $1,000, which is a lot of money, you can buy a conventional bond that has a maturity value of $1,000, has a maturity date of 4 years, and pays 5% annual interest. So we're going to calculate the interest that the investment earns annually by completing the table. Okay. So again, bear in mind that the interest earned is paid to you and not reinvested. Okay, so here's the idea. Here's the basic idea about a bond, this kind of bond. You give someone $1,000, okay, and they give you like a little certificate, the bond, okay, and you have to give that money to them for 4 years, okay. But every year at the end of the year that you let this person have this $1,000 of yours, they will give you 5% of that $1,000. Okay, so let's calculate that. So after the first year, when you gave them $1,000, they're holding on to that $1,000. They give you a certificate. You then calculate $1,000 times 0.05. Well, what is $1,000 times 0.05? It's gonna be $50, right? I mean, you can see it right there. 1,000 times 50 is $50. Okay, so there it is. And so then the value of that investment, $1,050, right? Because you add that $50 onto $1,000. Okay, you don't have that $1,000 right now, but you will get it back after those 4 years. Okay, so then step 2. Okay, year 2, you still have that $1,000 that you gave them. They still have that $1,000, or maybe they used it, whatever kind of thing, but they still have that IOU to you. They're going to spend another 5% on that $1,000, so that's another $50, and so now 1,100 total, right? Because you're going to add a 50 onto that 1,050. Same thing's going to happen again, right? After year 3, they still have that IOU to you for $1,000, so they're going to give you 5% of that, so now it's 1,150. And then finally here, after that 4th year, after you get that $1,000 to borrow, $50 again, so $1,200. Okay. And so there is what you total will have received. Okay. At the end of year 4, when the bond matures, they have to give you that $1,000 back. But then in the meantime, for them thanking you, basically, in a way of speaking, for them to thank you, they pay you to have that $1,000 that you lent them. So you lend them $1,000, and then this person, at the end of every year, agrees to pay you 5% of that money, so 50, 50, 50. So on top of the $1,000 they have to give back at the end of year 4, they're also going to give you $200 additional dollars too, just for letting them borrow that money for that long. Okay, so that's the idea of kind of like a bond there. Okay, questions on any of that? So that's the idea. Okay, that's the idea. And that's, for example, why banks pay you money to hold on to your money in their accounts. The idea is that if they get enough people to give them all this, the banks get enough people to give them all this money, they're able to loan that money out to other people at a higher interest rate, so that way the banks can make money. Okay, so the bank thanks you for putting your money in it by giving you that little interest rate in your savings account or whatever, so that they can then use your money to then loan it out to other people. Now, of course, if you go to the bank and you ask for your money, they're going to give you your money, right? They're not going to say, oh, I'm sorry, we can't give that money to you. It's been loaned out to somebody else. You can go get your money whenever you want. But if everyone were to go and ask for their money back from the bank, then the bank would be in trouble because they don't have everyone's money all total. They've loaned it out to other people. Okay, so anyway, sorry. Now, for $822.70, so less than $1,000, you can buy a zero coupon bond that has a maturity value of $1,000, has a maturity date of 4 years, and pays 5% annual interest. Calculate the interest that the investment earns annually by completing the table. Bear in mind that interest earned is reinvested and not paid to you until the bond matures. So this time we're not going to get paid at the end of every year. Instead, that money is going to get put back in and then reinvested. And at the end, you get the lump sum of your insurance money, or interest money, sorry. So let's see here. So starting at this, $822.70, we're going to now find 5% of that to earn the interest on it. So 822.7 times 0.05. And I get $41 and, well, 41.135. Okay, like that. $41.135. Okay. Okay. But again, we don't get paid that. Instead, we're going to add that to, it gets reinvested. So it basically gets added to the initial amount here. So we're going to add that to okay, and so we get 863.835. Okay, and I know technically here there's not thousandths of a cent, but we'll stick with this just to see how it goes, okay? I'm not sure if we were supposed to keep that or not, but we'll keep it for now. Okay? So that's your value of that's the value at the end of the year, first year. So then what number should go here? 863.835, because that's what we just ended the first year with, so we're going to start the new year with that same amount. Okay? Because the interest was reinvested, so it was added to the initial investment. Whereas here in the original one, that $1,000, we get paid that $50 off the bat. So we don't get, we just get the $50 there, that's it. But that, in this case, the interest that we get paid is really reinvested. And so we have now here. So now we'll do the same thing. We'll take that 863.835 and we'll multiply that by 0.05 now for this year. All right, I'm just going to start rounding now because it's a little too much. So I'm just going to say 43.19. Okay. Notice what happened here. The interest we got in year 1 was $41. The interest we got in year 2, $43.19. So the amount of money we earned went up. Why? Because, yeah, we're getting interest on the interest, right? Our value of our investment increased, so then the interest of that investment is going to increase as well. And so we get then the 863. I'm going to just start rounding now. So I'm going to make that 84. I'll make that 43.19. So 863.84 plus 43.19. I will say that I probably should just round down automatically. I think a bank, even if it's supposed to round up, the banks will still round down. I'm pretty sure that that's how it works, unfortunately. So I think they always just round down. But I'm going to round up here just because. Okay, so now we're at 907.03. We'll do the same thing here, 907.03. We're going to take that quantity after year or at the beginning of year 3 there and multiply by 0.05. Okay, and now we're at 45.35, we'll say there. And so then we're going to take that 907.03 and add the interest of 45.35. Okay. Now we get 952.38. Yes, I'm sorry. On like the, yeah, I'm sorry. I can zoom in some more. There, is that better? Yeah. Okay. I'll try not to move anything here too, because otherwise it'll get off the screen. All right, so now we're at 952.38 for the end of year 4 here. Okay, we'll multiply that by 0.05. Get to 47.62. I'll round that to, whoops, why am I putting that there? 952.38 gets multiplied by the 0.05. Get 47.62. Okay, and then we'll do the 952.38 plus that interest payment. And it should give us $1,000 there. Okay, and I think it does. 952.38 plus 47.67. Yep, that gives me $1,000.05. So I must have, or 62. I did the wrong. It's supposed to be a 2, Mr. Widmeyer. There we go. I copied that down wrong there. And we end up with $1,000. Okay, now let's look at some differences here, right? In both cases, we end up getting paid back $1,000. Okay. This one, though, had the initial investment. We had to give them $1,000, and we get back that $1,000 plus $200 more by the end of the time here. So we started with investing $1,000. We get back $1,200 at the end. And so how much money did we make? $200 for doing nothing, except for just being short $1,000. Okay, which could be significant. You know, maybe you need that $1,000 at some point, and it's like, you know, it's put away for 4 years. Compare that to this right here. Okay, how much money did we invest here? Well, we only had to invest $822.70, and we end up with $1,000 at the end. So let's see here, 1,000 minus 822.70, we get $177.30 total is what we made off of that. Okay, again, for nothing other than just letting them hold on to your money for you. So we still made more money here, okay, but we started with a different amount. We started with a larger amount, so we had to give a larger amount of money too. Here, we started with a smaller amount of money, and we still made pretty good. We made $177.3. Okay, dollars there for, again, doing nothing. Okay, so let me jump here. So that's kind of, again, just showing you the difference between the different ways that you can calculate interest and stuff like that. Yeah, okay. So I'm going to give you guys a formula here, and this formula you will not need to memorize. It will be given to you, okay? And so we're going to talk about then modeling interest that is compounded annually. So here, for example, the interest on this bond was compounded once a year at the end of the year, okay? At the end of each year, we did the interest calculation. But you can also do you can calculate the interest like every half year, so biannually. You can calculate the interest monthly, and so that is better because you get that little interest payment, you know, every month, and so you're adding interest to more interest and stuff like that. And so it's a little better normally to have more number of times compounded. But anyway, so this formula right here, we're going to ignore that one for right now. I've got a better one that is more generally useful. Okay, so compound interest n times per year. Okay, so sorry, I'm running out of space here. We'll just do it this way. Okay, so we're talking about compound interest n times per year. N is just the number of times compounded per year. And the formula for that is this. F of t equals a times 1 plus r over n to the nt. 1 plus r over n to the nt. Now, we've seen some of these variables before. What does this a, this number out front, typically stand for? The initial value of your account, right? Okay, what does r typically stand for? In these problems that we've been doing with exponential growth, exponential decay, what does the r stand for, typically? Percent interest rate as a decimal, though. So the interest rate as a decimal, right? T, what does T typically stand for? Time. In this case, it's going to be years. In this case, it'll be years, yep. And then N is just the number of times the interest is compounded per year. The number of times the bank gives you that little, you know, interest calculation kind of thing. Okay, so I'll write that out here. So A is initial amount. R is the interest rate as a decimal. Okay, R is interest rate as a decimal. N is number of times compounded. and then T is number of years. Okay? Okay, so let's take a look here at a situation. So for example, letter A, a person invests $3,500. So what variable will that go in for? Initial, or A. So that's going to be like our little A there. Okay, I'm going to put a little A of it just to remind me. At 3% annual interest, what does that 3% go in for? R, but it's R is equal to what number? Nope. What's the interest rate? 3%, but what's that as decimal? 0.03. Okay, this is not exponential decay, it's growth. So we're growing by 3% each time. Okay? Good. Now, another little thing here that I don't want to skip over, it's growing at an annual interest rate of 3%. So it's yearly, right? We get the interest at a yearly rate, and so that means what's our number of times compounded per year? N equals 1. This is an annual interest rate. You get it once a year. Okay, and then finally, T is the number of years. Well, that's what we're supposed to find. Find when, so T equals what? We're trying to find T. The value of the investment reaches $10,000. So we want to set this up. 3,500 times 1 plus 0.03 over, again, N we said was 1. It's compounded 1 time a year, to the 1 times T. Okay, we just plug all our pieces in. Again, you won't have to memorize this formula, but you'll need to know how to use it. What do we want this to equal? 10,000. Okay, 10,000. Okay, 10,000. All right. So, we can't solve this. Again, look where our variable is up in the exponent. So how do we solve this if we can't use algebra to solve it? Graphing calculator. So we're going to go to our y equals. I'm going to graph the 10,000. And I'm going to graph the 3,500 times, and then be careful how you type this in. So 3,500 parentheses, 1 plus. I'm going to see if I can get both things on the screen here so you can see. There we go. Okay. I'm going to put that 0.03 over 1. I'm going to put that in parentheses, inside the parentheses. So you see that? I've got 1 plus. So there's the 1 and the plus. I'm going to put that 0.03 over 1 in parentheses. Of course, if you wanted to, we could just simplify. What is 0.03 over 1? It's 0.03, right? We're just dividing by. So you don't even need. You could just put 0.03 in there without the over 1 part, because it's just 0.03. So if you wanted to, you could do that too. So we close the parentheses there for that whole quantity, because it's that entire quantity that gets raised to the 1 times t. So you're going to put a little caret there to the, and the exponent button's right there below the clear button. I would open up another set of parentheses here and do 1 times t. Again, because it's just a 1 times x there, you could just put an x, you'd be fine. But again, I think it's a good habit just to put a little parentheses in for your exponent there. So it's 1 times x in the parentheses there. Okay, so do we see that? 3,500, parenthesis, 1 plus 0.03, close parenthesis, caret for the exponent, 1 times x. Okay, now we're going to graph this. But can anyone go ahead and tell me what's going to be a problem I'm going to run into here? It's going to be way off the screen, right? It's way off the screen, okay? What's the highest y value we're going to need to have for our window here? 10,000 at least. So I'm going to go maybe up to like 1,200, okay? 12,000. So I'm going to do y max instead of 10. That's way too low. I'll do 12,000. Okay, now let me graph it and see what I get. Aha! I can see my vertical line there. Or sorry, horizontal line. Okay, it's not going to reach. So I think I'm high enough. Now which direction do we need to adjust our window? Right. To the right. So I need to adjust the x what? Max. X max. So let's go to window. What do you guys want to guess for the x max here? 50. Let's go to 10,000. All right, 10,000 might be. Let's try 10,000 and then we'll try 50. Okay, so there's that. Yeah, okay, there it is. So might have been too far to the right because we don't even see the line anymore now. Let's try 50 and see what happens. Come on, little curve, you can do it. All right, they intersect. So now we'll find the point of intersection. Second trace, intersect, first curve, second curve, and I'll move in towards the 0 there for the guess. Or not the 0, the intersection point. Aha. 35.5, we'll say. 35.5 years. Okay. I know that's not, it doesn't seem like a lot. It is, kind of unfortunate, right? You have to give someone $3,500, and then 35 years later they'll give you $10,000, right? So. Yeah, 3%. I'll say this: 3% is really high for a bank, but it's pretty low for like stocks or mutual funds and stuff like that. That's pretty low. Okay, 3%. Yeah. Well, anyway, I don't get too complicated here, but 3%. Yeah. It's almost just as good to hold on to the money. Well, not really, I guess. It'll get worse if you just hold on to it. Never mind. Anyway, so there's that. Okay, $10,000. But it is, it is still, you're like more than almost tripling it, right? To get from 3,500 to 10,000, it's almost tripling it. A little bit less than tripling it. So anyway, all right, let's try another one here. We'll skip. I think we'll skip these. I want to skip to ones where we actually have other compounds per year. Okay. So let's skip to the next page here, page 684. Okay. Interest may be earned more frequently than once a year, such as semi-annually. So semi means half, so semi-annually, every 6 months. Quarterly, 3 months, right, is a quarter of a year. Monthly, that'd be 1/12, right, of a year. Or daily, that'd be 1/365th of a year. Okay. If the number of times that interest is compounded in a year is n, then the interest rate per compounding period is r over n. Okay. So here's one thing I also want to try and describe here. If you have an annual interest rate of 3%, okay, but the bank says, oh, we'll compound that every month. They don't give you 3% every month. They give you 3/12% every month. So that then over the total of those 12 months, you'll get a total of 3% interest. But they give you a 3/12 in January, 3/12 in February, 3/12, 3/12, 3/12, so on and so forth on the way down until it then adds up to 3% at the end of the year. Okay. But that is still a better deal. It still gets you, your money grows faster that way than it would if you were just getting it at 3% all at the end of the year. Okay. So 3% split up over 12 months gives you more interest total than 3% at the end of the year. And why? Because your interest is gaining interest. When you get that little interest at the end of January, then February's calculation includes that interest, and so it grows a little bit faster because you're getting that, more. You're getting a little bit of interest a little bit sooner. Anyway, okay, let's jump down. So here's one, for example, right here, letter A. A person invests $1,200, so there's your initial amount, in an account that earns 2% interest compounded quarterly. Okay, so 2% is our interest rate, 0.02. Compounded quarterly means how many times per year is it being compounded? 4, right? 4 quarters in a whole. Find when the value of the investment reaches $1,500. Okay, and so here's the setup for you. You can see they got, then sometimes instead of A, they use a capital P for the initial amount. Okay, the capital P stands for the principal, which is like the starting amount. Okay, the principal. So $1,200, boom. Okay, you can see there's the interest rate R, 0.02 divided by 4. Okay, right there, and then to the 4t. Okay, and then they solve it, find where the two lines intersect, and it's about 11.2. Okay, so a 2% interest rate to get from $1,200 to $1,500, it takes about 11.2 years. Okay, 11.2 years. Okay, so question on any of that so far? All good? Okay, let's go down here a little bit more then. Let's try letter B. We'll set this one up for ourselves here. And I think, yeah, okay. we'll do two more here. We'll do this one and then one more. Okay? So letter B, a person invests $600 in an account that earns a 6.25% annual interest compounded semi-annually. Find when the value of the investment reaches $1,700. Okay? So that 600 is our what? A. A is 600. Okay? 6.25% is the interest rate, but as a decimal, it will be R equals what? 0.0, yeah, 625. Interest is compounded semi-annually, so how many times a year? Semi is two times a year. If it was 6 times a year, it'd be like bi-monthly, like every 2 months. That'd be 6 times a year because there's 6 pairs of months. Okay, and then find when, so we're solving for t. T equals, you know what? When the value of the investment reaches $1,700. Okay, so let's set this up here. They have it all written up here. I'm just going to write it down here. So 1,700, we want to know when that equals 600 times 1 plus R, 0.0625, over N2 to the NT, so 2T. Okay, and I'll zoom in on that there for you guys, sorry. Okay, there's our situation. Okay, again, we can't solve this yet. We'll be able to eventually solve it without a calculator, but right now we're going to solve it with a calculator. Okay, so we type this in. Okay, 1,700 in for Y. And then be careful you type this next one in. So I'm going to show you that here real quick. I'll show you here. Okay, it's going to be 6. Oh gosh, I got to get like more screens or something here. Let this all show up. There we go. So I got to have 600 times 1 plus, and again, 0.0625. So I'm going to put that in parentheses. 0.0625 divided by 2. So I close the parenthesis for that one, but I got to close the parenthesis again. Okay. To the parentheses 2t, or 2x in this case, right? So there it is. Okay. If we graph this, oops, I think I have a 17,000. I have one too many zeros there. There we go. Okay, there's 1,700. Now we have our point of intersection. So second trace, intersect, 16.9, so almost 17 years. Okay. By the way, if I see 16.9 years, does that mean that it's 16 years and 9 months? No. But it's 0.9.
It's going by 10.
Right. 0.9 is what fraction? 9 what?
10.
Tenths. Months is something out of 12. So if you want to figure out how many months it's going to be, you got to do 9 out of 10 equals x out of 12. Cross multiply and solve here. So 9 tenths, 9 times 12 divided by 10. 9 times 12 divided by 10. It's actually in October. Okay? 9, when you solve this, you get x equals 10.8. So it won't happen in September, 0.9, right? You think, oh, it's the 9th month, September. Nope. It actually happens in October. It's at 10.8 when you solve there. So it's almost November, really. 10.8 is almost the 11th month, November. Anyway, that's another little aside there. Okay, so about 17 years is when it'll take that. All right, one more thing I wanted to look at here. And that's going to be on the page 688. Okay, 688. Okay, and this is really going to be useful for you guys when you go and try and make a decision about what bank you would like to, use. I'm going to guess most of you are probably going to use the same banks your parents use. At least that's where you're going to start because that's just what you're familiar with. And that makes sense. I get that. But if you ever want to shop around to see which bank you should choose, this is a good way. You can kind of compare and see, okay, well, this bank offers me, an interest rate of 4.24%, and they compound it annually. So that's once a year. So it's a little bit higher, but it only comes once a year. Whereas this bank offers me a smaller interest rate, but they compound it daily. So we want to see, which one is going to give you the best, kind of amount, or give you the best kind of deal or kind of thing. Okay. So let's see here. We need to come up with kind of like a starting amount of money. So let's just say we're going to put in $100. Okay. So A equals 100, and for this first one, it'll be 1 plus 0.0424 for the interest rate over 1 to the 1 times t, so just t. Okay, so that's that first one. Compare that to 100 times 1 plus, and now it'll be 0.0418 over compounded daily means how many times per year is that going to be compounded? 365 to the 365t, like that. Okay. And so let's just compare these two things here and see what we get. Okay, so I'm going to graph both of these. All right. So let's see here. So 100. So I'm going to graph this one in y1, this one in y2, and kind of see how they compare. So 101 plus 0.0424 to the t, to the x, and then 100 parenthesis 1 plus 0.0418 over 365, excuse me, to the 365t. I'm going to adjust my window. Since my initial amounts are starting at $100, I'm going to say my window, let's make my y max be like 200. I'll just double that. All right, and let's see here. So I just doubled my window here, so let's see. Okay, so there's the first curve. I think my screen is like all funky. There it is. Okay, there's the first curve. And I can't see the second curve. Alright, let's see if I can fix that. I'll make this curve be like thicker. So there's the first curve, the first calculation we did. And there's the second curve. Alright, so it looks like it's like pretty much following along that other curve pretty closely. So let me see here if we can like maybe go further out to the right here. So I'll go out to like 100 for my x max. It's following pretty closely there. Maybe I need to go up higher. Try 1,000. Okay, that's too much. I think I went out too far. Oh, I went to x max. Darn it, I went way too far there. Sorry, that should be 100. I put this to be like 1,000. There we go. I adjusted the wrong thing. Sorry. Okay, so then there's again that first bank account. You can see it's kind of going along there. Second bank account. Oh, they're still pretty close there. Let me try even greater amount of money. Or not great. Let's go to like 5,000 here and see if we can get this to do anything. They look pretty similar. All right, well, I think they do intersect at some point here. Let's see. Huh. Interesting. It's not really showing too much of a difference here. Let's see. I'll go to my table instead then here, so we'll do it that way. Compare it that way. And I'll go to table set. I'll go back to auto here. Let's see if we can do it this way. Figure this out. Okay. So you can see here, for example, after 5 years, the first account has $123.08. The second account has $123.24. Okay. In fact, if you look all along these, that second account always has a little bit more money in it. Right? 128.5, 133.73, but 133.99, 139.4 versus 139.71. And as you keep going, it should give you even further and further apart. So let me start at like 100, although we're not going to go to 100 years, obviously. You would not. But it does get further and further apart. So it looks like that second account is the better deal. Okay, so it looks like you probably want to go with account Y. Just because it always seems to give you a little bit better. Again, compare that in the table. The graph wasn't very helpful, so I apologize. Maybe we should have just gone to the table in the first place. If you go to the table and we compare, even after 1 year, that first account is a little bit less than that second account is, and then it keeps getting wider and wider and wider, the difference. So you want to go with account Y there. Okay? Questions on any of that? All right. So let me get you guys started then on your assignment here. We're going to be on page 689. Okay, 689. Okay, and let's see here. All right. Okay, so let me have you guys do on page 689, I'll have you numbers 1, goodness, I don't know, some of these are just, they're all kind of very similar here. So I'll have you do like 1, 3, 5, and then number 8, so 1, 3, 5, 8, and then also 12. No, sorry, not 12. 14. 14. Okay? So 1, 3, 5, 8, and 14. I think that's all I'm going to have you guys worry about. Yes. 1, 3, 5, 8, and 14. Again, that's starting on page 689.